Hello, hello, hello. Today I am going to hit a cushion with a stick. So I'm going to look at rate of change of momentum. This is the final in the forces episode. So far we know that we need to remember these three equations. We need to remember momentum is mass times velocity, and we use P for momentum so it doesn't get confused with M for mass. We know that force equals mass times acceleration, and we know that acceleration is change in velocity divided by time. Delta, which is the triangle representing change. Right, okay, so if I take this equation, and I take this equation here, and I substitute this in for the A, then it can be shown that F equals change in mass times velocity divided by time. And all I've done is I've put the VT in for the A from that equation, and I've shifted the delta symbol to the left. So, in other words, what's going on here is that force is equal to the change in momentum divided by time. Now, this is a really important equation in terms of safety. It's connected to your seat belts, it's connected to your airbags, it's connected to the soft cushioning that you get under swings at playgrounds. Okay, so all of this is got real practical implications for impact damage. Okay, right, so I have a friend, he's not really a friend, in his spare time he goes to the top of multi-storey car parks and he throws melons off the top. Sometimes he likes to recycle his melons, so he puts a mattress down. So no mattress, melon gets chucked off the top, okay, and it cracks against the floor. Oh, there's a bit of a phone wobble there, sorry. Okay, so more likely to be damaged. If my friend puts the mattress down, sometimes, most of the time, it stays intact. Okay, and that's because of cushioning. What happens is, if, okay, I don't have the cushion there, yeah, it bounces off. Okay, if the cushioning's there, then the amount of time that the object is making contact with the cushion, okay, is increased. You've increased your impact time. So therefore you have cushioning and this cushioning effect. So let's have a look at the equation. Okay, so if we reduce the force and we reduce the change in momentum, then we're going to decrease the damage. And because this is on the bottom, it's inversely proportional. So we need to increase that impact time. So this is why it is better to hit your head against an airbag against full force against the steering wheel. Okay, airbag, steering wheel. I'm enjoying that far too much. I will stop. Okay, so if you get asked about this, okay, that's the equation. It's given to you on the data sheet. To reduce the impact damage, you need to reduce the amount of force experienced. That is achieved by reducing the change in momentum. Okay? That's important. Don't put change in, you ain't getting any marks. Okay? And what you have to do is you have to increase the impact time, which is why cushioning is a good idea. Yeah, thank you.